After the historic and successful adventure carried out by ISRO's Chandrayaan 3, what is next for the maverick and highly ambitious Indian Space Research Organization, that is space docking, which we'll be discussing today. Now, this is what the experiment ISRO is currently carrying out, SPADEX. Space docking experiment. We'll try to define and understand what is meant by space docking, but we'll also understand the mechanism of space docking and also what it holds for ISRO and India as well as the world in the future. So, space docking, if I want to define first, it refers to maneuvering two objects, two objects or satellites here in an orbit which are far away from each other, bringing them closer together and then finally connecting them. Like we have docks for ships, the harbors for ship where they dock, they rest their anchor and stay there. So similar is the process of space docking. Now you can see here, this is the International Space Station and the moon. So obviously it has implications for India's next ambitious mission, that is going to be Chandrayaan 4. Now what is going to be the main objective of Chandrayaan 4? That is to collect lunar rock samples for analysis, and obviously this time, unlike Chandrayaan 3, it's not going to be just about landing, conducting research, and then sending back signals. It is about collecting the material, the requisite samples, debris, and then sending it back home without fail. So that is where space docking comes into place. And second most important thing is India, by the time from the period of 2028 and 2035, on the lines of International Space Station, it hopes to establish its own Bharatiya Antariksh Space Station, which will be an unprecedented achievement. And how will space docking work? Basically, if we try to understand, so let's take an example of how Chandrayaan 4 aims to establish. So we have already established the basic or discuss the basic function. So there will be two, this will, for example, this is the Earth and this is an orbit in which two spacecrafts or two satellites A and B are revolving around the Earth. So initially they will be at a distance, and in order to bring them closer together, they will, one will be the chaser, one will be the target. So it is moving in these directions, and they will be brought closer together and they will be docked. And why it is essential? Because the International Space Station has not been built in one go. It is a large entity. Separate modules, separate components have been brought back and then sent time and again, and then they are docked or connected together. You can imagine the space docking as connection of jigsaw puzzle pieces. So they have been connected to form a large entity, and these docking modules, they are used to replenish or send back or receive astronauts the various supplies. So that is why space docking is important. Now, one very important example of how the lunar Chandrayaan 4 aims to achieve, a very interesting example. So, if this is the Earth, just for information, PSLV C60, the workhorse PSLV rocket, was used to launch the SPADEX, the space docking experiment modules. And here for the lunar, we are taking the example of lunar. So what will happen is, if a spacecraft like PSLV, it will launch two a propulsion module first, which will carry two or more modules into the Earth's orbit, and then it will transfer it to the orbit of the moon. This will be the transfer module. So transfer module will have an ascender slash descender satellite or object attached to it. It will detach, it will land, it will collect the samples from the moon. It will then ascend, then redock with the transfer module. This transfer module will again enter the Earth's orbit, and then the heat resistant materials will help this transfer module to make a re-entry into the Earth's atmosphere and land. Okay, now when we come to the basics of this experiment, so these are two satellites just for illustration purposes. So how they are going to work. So the launch, as I have already said, that it has taken place. Okay, just so the launch has already been taken place. So two different modules weighing around 220 kg each have been placed in an orbit roughly 470 kilometers from the Earth. Okay, now the two separately. So one is known as the SDX-01, which is the chaser, and the other is the SDX-02, which is the target. Okay, so they are rotating in the orbit. So currently, as of 6th January, the the chaser has not yet caught up with the target. The docking process has not yet concluded. So after the aim is they have been launched. Okay, so they, by providing a relative velocity, they have been forced to drift apart. So they were launched together, but they have been forced to drift apart to establish a distance of around 10 to 20 kilometers. Okay, via propulsion thrusters. And now, once they have started revolving in this orbit, now this velocity of this chaser, it will slowly be increased and it will start chasing. These are both moving, so it has to chase and then attach itself with this. And approximately it is estimated that by 9th January, in a day or two, we'll know the status. All the videos of the chasing experiment of that have been released by ISRO, so you can view those on the net. So this is how it is going to work, and this is just two small objects compared to the scale of what ISRO aims to establish in the long run with the construction of the International Space Station, which is going to contain much heavier, much larger experiments, much larger modules. And again, cameras, tilting cameras are there to monitor and visualize, to analyze how the space docking is going to take place. And also electrical signals are going to be passed so as to affirm when the docking has taken place. And then finally they will again undock, and SDX-01 and SDX-02, they will keep rotating in the orbit, but they will start conducting their other pending experiments. Okay, so this is what is about the what the experiment is all about. And the important thing, one of the most important thing about this is, apart from the space docking experiment to establish this milestone, apart from this, the some in the fourth stage of the launch, the poem stands for PS4 orbital experiment module. This will be used for conducting several important and noteworthy experiments. So this is one primary feature. Next, what will be the technologies, the latest technologies that will be used or have been used, which differentiate enormously this mission from other PSLV workhorses mission? First of all, the use of mobile platforms. The main center for launching these satellites or the spacecraft is the Sriharikota Center. Now, till now, like this is a platform for launching. So till now, what used to take place that the area where from where the spacecraft has to be launched, there only the spacecraft was assembled. But now the spacecraft has been individually, it has been assembled, constructed at a different place, and via mobile platform, it has been brought to this launch site. So that is an achievement in itself. Okay. Then the different modern sensors like the laser rangefinder, the docking sensor, these new technologies, the rendezvous sensor, these technologies have been used. Then use of a new processor which will use relative velocity. Relative velocity is actually a physics term. It means the difference in velocity between two modules, which we have discussed, the chaser. So that is relative velocity. It will use relative velocity and position to conduct navigation. So we don't have to control the rovers or control the spacecraft or modules from any center or manually. The module itself, when it is conducting experiments, collecting samples, by using this processor on the basis of relative velocity position, it can dock, undock, and do various other experiments. Fine. And second is other testing capabilities like vertical docking experiments, rendezvous, rendezvous meetings, rendezvous meetings in real time validation. So once the docking has taken place, how to validate that they have not just come closer to each other but have actually docked together. So that is rendezvous. Okay. Then what all experiments? We talked about POEM, PS4, orbital experiment module. So first, very interesting, CROPS. So this stands for Compact Research Module for Orbiting Plant-Based Studies. So recently this image was shared by ISRO. So you can see this image. It is an image of a sprouting or germinating cowpea. This is cowpea or lobia. So this you can see in microgravity, in almost zero gravity, ISRO using its advancements technology, it has been successful in growing, in sustaining a two-leaf branching and germination, sprouting of this cowpea. So this is biological experiment, very important. Second is this image was also shared, the functioning of the robotic arms. Robotic arms for collecting debris, for collecting lunar samples, which will be very helpful. Okay, what else? Apart from that, some universities like the Amity University, they are involved in conducting microgravity experiments, plant-based studies, and RV Engineering College. It will monitor the growth curve of gut-based bacteria in microgravity. Gut bacteria. So all these, this is why it is very essential. And finally, we come to the docking phase. It will be informed. It will be much in news when it finally happens. Okay. So this is mostly about what is important going on, not just for any competitive exam, for increasing general awareness. What all of whatever lectures I have conducted, you can see a relation. If you relate this with the PSLVs, the stranding of the two astronauts, and the other space research missions, the Chandrayaan and others which we have discussed, so these are all connected. Okay. So it is not just to establish the prowess of ISRO in the space sector. It not only places it in an elite list of countries like Russia, China, US, but it spells a lot more. It is, in terms, if I quote Neil Armstrong, it's a small step. It is just a small step taken by ISRO which will benefit whole of the mankind in the future. And obviously, at the last, not only the docking mission, India also aims to send a person, man or woman, to the moon, a manned space mission. So for that also, all these experiments, all these precursors, predecessors, they are very much of noteworthy importance. So with that, we conclude for today. Till next time, Jai Hind.